Hi friends, first of all, thanks for being here as part of video series, video lectures. Today I explained to find the two non-singular matrices P and Q such that PAQ is normal form. So let's go to the theory. If A is a matrix of order m by n, then there exists a non-singular matrices P and Q such that PAQ is normal form. So these are the normal forms. PAQ is the normal form. This is the normal form. This is the one of the normal form. These are the one of the normal form. These four are standard normal forms. So the matrix is reduced into normal forms. So let's go to the problem. So suppose A is an m by n matrix. A m by n matrix equal to, so this can be written as, for real numbers, so 2 can be written as 2 into 1. So in the same way, 2 equal to written as 1 into 2 into 1. So this one is called prefactor of 2. The same way, this one is called post factor of 2. సో 2 కన్నా ముందు ఉంది కాబట్టి దీన్ని ప్రిఫాక్టర్ అంటారు. 2 కన్నా బ్యాక్ ఉంది కాబట్టి 2 తర్వాత ఉంది కాబట్టి దాన్ని పోస్ట్ ఫ్యాక్టర్ అంటారు. ఇన్ ద సేమ్ వే ద మ్యాట్రిక్స్ ఈజ్ ఆల్సో రిప్రజెంటెడ్ యాజ్ ఏ ఎం బై ఎన్. అంటే దట్ మీన్స్ ఏ ఈజ్ ఏ మ్యాట్రిక్స్ ఆఫ్ ఆర్డర్ ఎం బై ఎన్. హియర్ ఎం ఈజ్ నెంబర్ ఆఫ్ రోస్, ఎన్ ఈజ్ నెంబర్ ఆఫ్ కాలమ్స్. సో దట్ దిస్ కెన్ బి రిటన్ యాజ్ ఐఎం into A into IN. So IM is called prefactor of A. Here IN is called post factor of A. Here identity matrix of order M. IM means identity matrix of order M. M means the number of rows in the matrix A. And the same way IN is the order of the identity matrix N, the identity matrix of order N. So N means the number of columns in A. Now once we write the given matrix in this form, now here the prefactor of A is formed based on number of rows in A. In the same way, post factor of A is formed based on number of columns in a matrix A. So that you apply row operation on A, row operations on A, the same row operations applied on prefactor of A, only prefactor of A on right hand side. Suppose we have to apply column operations on A, the same column operations applied on post factor of A, because the post factor is formed based on columns on A on left hand side. So that in left hand side A, we apply column operations on left hand side of A, the same column operations applied on post factor of A on right hand side. So we continue this process until the left hand side matrix is reduced into one of the normal forms. Okay, we continue this process. We apply the operations on left hand side of A until the left hand side of A is reduced into the above one of the normal form. The way Im is converted into Im is converted into P and In is converted into Q. So finally we get normal form equal to P A Q. So this is the title of this PPT. Okay. Here we have to find out, here P is a non-singular, we have to find out two non-singular matrices P and Q such that PAQ is normal form. So this theory is explained through an examples. Let's go to the problems. The first one, find the two non-singular matrices. Find the non-singular matrices P and Q such that PAQ is a normal form where A equal to 1 2 minus 2 minus 1 3 0 0 minus 2 1. This is the given matrix. So we observe that. So we go to the solution. This is the given matrix. So since A is matrix of order 3 by 3, so number of rows is 3 and the number of rows columns is also 3. So that A, the matrix A can be written as I3, that means number of rows in A, identity matrix of order 3, A, and identity matrix of order 3, that is columns. So this is prefactor, this is post factor, this is post factor. Now our aim is to reduce on left hand side of A. This is the left hand side of A. This can be reduced into one of the standard normal forms. So this is the 3 by 3 matrix. So once we applying elementary row and column operations, this matrix is reduced into one of the possible normal form. I3, I3 means 1 0 0 0 1 0 0 0 1. This is I3. Or the second normal form is I2, I2 0 0 0. I2 0 0 0. That means 1 0 0 0 1 0 0 0 0. So either we go for this form or this form. We observe that in the first row, the first element is 1, the remaining all elements is 0. In the same way, in the first column, first element is 1, the remaining all elements are 0. So that, so we make this one, this is 1 is 0. Now we have to make minus 1 and 0 as 0. So that we have to apply R2 tends to R2 tends to R2 plus R1. So minus 1 plus 1, 0. In the R3 row, the element 0 is already exist. So that can be, so we have to apply any operations on R3. So that, so we have to apply first R2 tends to R2 plus R1. So 1, 2 minus 2, that row is not affected because we don't apply any row operations on first row. So R2 tends to R2 plus R1. So minus 1 plus 1 becomes 0. The same way, 3 plus 2, 5, 0 plus of minus 2, minus 2. So the remaining in the third row, the elements are same written 0, minus 2, 1. So now we have to apply row operation on left hand side of A. This operation are applied on prefactor of A on right hand side. Prefactor means I3. So the same I3, 1 0 0. The first row is same written. In the second row, 0 plus 1, 1, 1 plus 0, 1, 0 plus 0, 0. The third row should be continue because we have to apply operation on only R2, not on R1 and R3, so that the elements in R1 and R3 does not affect it. So the operation, row operation is applied on prefactor of A, and A is written same, and post factor is also written same. These are to continue. Okay. Now our aim is to make these element as 0, these element as 0. So now we apply the column operation. This is C2. C2 means 2. So C2 tends to C2 plus 2 plus minus 2C1. C2 minus 2C1. So 2 minus 2 into 1, 0. The same way, C3 tends to C3 tends to C3 plus C2, minus 2 plus 2, 0. Or var C3 tends to C3 plus 2C1. So either first operation or second operation, both are gives the same result. In third element, in first element in the third column will be 0. So we get, so C2 tends to, so C2 tends to C2 minus 2C1, that can be explained in the side, and also C3 tends to C3 plus 2C1. C3 tends to C3 tends to C3 plus 2C1. Okay. So the first element and the second column first element and the first element in the third column is 0, 5 minus 2 minus 2, 1. So we have to apply the operations on column, so the rows are not affected. In the same way, we have applied these columns on these column operations on prefactor of, sorry, post factor of E. Okay, so that can be written as C3. C3 tends to C3 plus C2. So this element is replaced by 0 plus C2, 0 minus 2C1. So this is minus 2. So this is 1 that is not affected. This is 0. So minus 2, 1, 0. So here we observe that minus 2, 1, 0. The same way here C3 plus 2C1. So 0 plus 2 into C1, 1, 0 plus 0, 0, 1. That means 1, 0, 1. So sorry. C3 plus C3 plus 0 plus 2 into C1. So that is 2, 0 plus 0, 1. So 2, 0, 1. So we get 2, 0, 1. Okay. Now in the left hand side matrix, in the first row and first column contains only 1. Now we come to the second row and second column. So this is the 5. This is 5. So R2 tends to R2 tends to R2 plus 2 R3. R2 tends to R2 plus 2 R3. So 5 plus 2 into minus 2, 4. We get 1. So minus 2 plus 2 into 1, 0. So here 0 plus 2 into 0, 0. Okay. Now the operation is applied on prefactor of A. So only this matrix. Prefactor of A, because this is the row operation, we have to apply here only. So the first row is not affected. that elements are written same. The second row, 1 plus 2 into 0, 1, 1 plus 2 into 0, 1, 1 plus 2, 0 plus 1, 2 into 1, 2. Next, 0, 0, 1 is written same. A, the column matrix is written same. Now we have to apply, this is 1, 0. Now we make this element as 0. Now we make this element as 0. So for that we have to apply R3 tends to R3 tends to R3 minus 2 plus 2 into 1 R2. So we get 0, 1, 0, 0, 0, 1, 0. So minus 2, so 0 plus 2 into 0, 0. Next, minus 2 plus 2 into 1, 0. 1 plus 0, 1. Same row operation is applied on this matrix, prefactor of A, because we have to apply row operations. So row operations are applied on prefactor of A on right hand side. So we get 1, 0, 0, the same elements. So next 1, 1, 2. R3 1, 1, 2 is the same. Next 0 plus 2 into 1, 2. Next R3 0 plus 2 into 1, 2. Next 1 plus 2 into 2, 4. 1 plus 4, 5. So the matrix is written same. Now we observe that on left hand side of A is reduced into normal form I3. So this element is represented as a P, and this matrix is represented as a Q. So P, A, Q equal to normal form. Here P equal to 1, 0, 0, 1, 1, 2, 2, 2, 5, and Q equal to 1, minus 2, 2, 0, 1, 0, 0, 0, 1. We observe that here det P equal to 1 into 1 into 5 minus 2 into 1 into 5 minus 2 into 2, 4, that equal to 1, not equal to 0. The same way, like same way, det Q equal to 1 into 1, 1 into 1 minus 0, that equal to 1, not equal to 0. So we observe that P and Q are non-singular matrices. Also, rank of A equal to 3, because the order of the identity matrix in normal form is 3. So that rank is 3, and there exist two non-singular matrices P and Q. So this is the way to find out two non-singular matrices P and Q such that PAQ is normal form. Let's go to the next problem. Find two non-singular matrices P and Q such that PAQ is normal form where A equal to. Now we observe that A equal to. This is the matrix of order 3 by 2. 3 by 2 means number of rows, that is columns. So prefactor is formed based on rows and postfactor is formed based on columns. Number of rows is 3, so prefactor is I3. Number of columns is 2, so postfactor is I2. This is the postfactor. This is prefactor. Now we write A matrix. I3 means 1, 0, 0, 1, 0, 0, 0, 1, and A I2 1, 0, 0, 1. Now our aim is to reduce the left hand side matrix into normal form. So for that, this is the 3 by 2. So rank of A less than or equal to minimum of 3 comma 2. So that is less than or equal to 2. So rank is 2 or below 2. Suppose rank is 2, the one of the possible normal form is I2 0. I2 0. That means 1 0 0 1. Next 0 0. This is one of the normal form. Or I1, I1, 0, 0, 0. That means 1, 0, 0, 0, 0, 0. This is the one of the normal form, I2. So the matrix is reduced into this normal form. So we get this normal form, and the matrix is reduced into in this normal form. The matrix is reduced into in this matrix. So either A2 or I1, we observe that the first row contains 1 0, the first row contains 1 0. So that we make this element as 1 and we make this element as 0, so that we interchange R1 implies R2, R1 and implied by R2. So we observe that R1 implies and implied by R2. So the second row is replaced by first row is replaced by second row. So first of all, the second row is replaced by first row 1 3, the second row is replaced by 2 6, the third row is still constant, still placed in the same position. Okay. The same way, the row operations are applied on prefactor of A, that is I3. So in I3, the first row, this is the first row, this is the second row. The first row is replaced by second row, and second row is replaced by the first row. So 0 1 0, 1 0 0. The third elements, the elements in the third row are in the same position. So prefactor is also same. Now our aim is our aim is to make our aim is to make 2 add 0, 3 add 0. For that we have to apply the row operations. So R2 tends to R2 minus 2 into R1. So 2 minus 2 into 1. So అది ఏమవుతుందమ్మా 2 6 minus 2 6. So that value 2 minus 2 0, 6 minus 6 0. Okay. Next, R3 tends to R3 tends to R3 minus 3 R1. So that means R3 means 3 9 minus 3 R1 means 3 1 are 3, 3 3 are 9. That can be 0. So you write that. Here we have to apply R2 tends to R2 minus 2 R1, R3 tends to R3 minus 3 R1. We get 1 3, 1 3 is same, and 2 6 becomes 0, 3 9 becomes 0. So that is clearly observed in this slide 0 0. So now the same operations are applied on prefactor of A. So this is 0 1 0. The elements are still same because we apply the operations, row operations on only R2 and R3. So 1 0 0. So here R2 tends to R2 minus 2 R1. So 0 R2 tends to R2 minus 2 R1. So 0 minus 2 into 1. So that is R2 tends to R2 minus 2 R1. So R2 tends to R2 minus 2 R1. 1 minus 2 into 0. We get 1 same. We get 1 same. Next, 0 minus R2 means 0 minus 0 minus 2 into minus 2 into 1. Minus 2. So we get minus 2. Next, 0 minus 0. So that is 0. The same way, the same way, R3 tends to, here R3 tends to R3 minus 3 R1. So 0 minus 3 into 0, 0. So that is 0. Next, next, 0 minus 3 into 1, minus 3, minus 3. Next, 1 minus 3 into 0, 1. So 1. So remaining A is same, we write A as same, and post factor is also same. Okay. So now our aim is to make this element as 0. So for that we have to apply C2 tends to C2 minus 3C1. So 1, 3 minus 3 into 0, 0 minus 0, 0, 0 minus 0, 0. So 0. The same way, the same operations, here we apply the column operations. So the column operations is applied on post factor of A. Post factor of A. So here C2 tends to, C2 means 0, 1. C2 minus 3C into 1. So 0 minus 3 into 1, minus 3. 1 minus 3 into C0, that is 1. Okay. So now we observe that on left hand side, the matrix, the original matrix A is reduced into normal form I1 1 0 0 1 0 0 0 0 0, that is equal to PAQ. So here already I explained that 1 0 0 0 0 0. So the matrix, original matrix is reduced into the matrix I1 0 0. Okay, that equal to PAQ. Here we observe that det P, det P equal to 1, that is not equal to 0, and det Q equal to 1 into 1, that is 1, that is also not equal to 0. Also, in the normal form, the order of the identity matrix is 1. So therefore, rank of A equal to 1. Okay, rank of A equal to 1. So rank of A equal to 1. Okay. So this is the way to finding two non-singular matrices P and Q such that PAQ is normal form. So thanks for watching this video. If you like this video, please subscribe, like and share to your friends. Thank you, friends.